Hi, this is Tom Needham, and on today's episode of Sounds, we're honored to have Dr. Charles Camarda, a NASA veteran with an extraordinary career that has left an indelible mark on space exploration. Growing up in Ozone Park, Queens, not too far from here, Charles went on to become a mission specialist on the historic STS 114, the first space shuttle mission after the devastating Columbia disaster in 2003. In addition to his time in space, he has served as the director of engineering at the Johnson Space Center and as deputy director of NASA's Engineering and Safety Center. Dr. Kamada has been a relentless advocate for safety and accountability in the space program, unafraid to speak out against systematic issues and leadership culture at NASA. He joins us today, though, to talk about his career and his new book, Mission Out of Control, which addresses the loss of a research culture in a high risk organization. Dr. Charles, thank you so much for joining us today on the program. It's really an honor.
Well, thanks for having me, Tom. I appreciate your time.
Yeah, of course. So, your book, Mission Out of Control, addresses the loss of research culture in high risk organizations. What inspired you to write this book?
I wrote this book, Tom, because I was a researcher my whole life before I became an astronaut for about 22 years. And I was training in Russia when the Columbia accident happened. I lived through the Challenger accident when I was a researcher. And then the Columbia accident happened when I was an astronaut, and I was in Russia at the time. And when we were told that we had this tragedy by one of the cosmonauts at the Yuri Gagarin Cosmonaut Training Center in Star City, Russia, we rushed inside, we watched the TV, and we saw this huge piece of foam come off the external tank during the launch, hit the vehicle, looked like it hit the belly of the vehicle, underside of the wing, or the wing leading edge. Very fragile parts of the orbiter vehicle. This is where the thermal protection system is very fragile and usually can be damaged very easily. And so I immediately thought this was, we were very sad, but I thought this was crazy. How could people not believe that this was a serious problem, the people at Johnson Space Center, and allow this to happen? And when I came back from Russia, I started diving into not only solving the technical problem, but I was more troubled by the cultural problem. What was NASA missing? And so I dived into all the research from these sociologists, behavioral scientists, cognitive scientists, organizational psychologists, and I read hundreds of papers, several books. I interviewed several people, and it took me about 15 to 18 years to actually understand what they were talking about. And because I had worked at NASA for my whole life for 45 years, and I had been a researcher and been in multiple different cultures at NASA. When I became an astronaut, I immediately saw that the culture at Johnson Space Flight Center was different than what I was used to. And so this intrigued me. The only way we're going to fix this problem, since culture was the primary cause of Challenger and Columbia, and what we're finding out, other organizations like Boeing 737 MAX tragedies, the primary cause of that accident was determined to be culture also. So it took me a long time to understand what these sociologists were saying. And because of my research background, I realized that they didn't quite get it. They were missing something. And what I talk about in my book is what I've found out, what I discovered was that it was this loss of a research culture. We grew up, and NASA became an agency in the late 1950s, in 1958. Before that, the agency was called NACA, the National Advisory Committee for Aeronautics. And that was totally a research organization, three different NACA laboratories. And the purpose was to understand the theory of flight and make our aircraft industry the best in the world. And so I explained in the book how this research culture basically evaporated at NASA after the Apollo program. And what's the loss of that research culture, which was a psychologically safe environment. We were allowed to have tough discussions. It was all about understanding the knowledge and verifying the knowledge and vetting that knowledge with rigorous discussions and looking at the data. And so we lost this kind of psychologically safe environment where people were allowed to speak up and argue. And slowly the culture became toxic. And it led to two disasters. We were never able to fix the culture. And what I talk about in the book is this culture persisted even right after the Columbia accident, leading to almost two near misses, one on my flight, one on the flight after mine. And and it's we see it today with the our mission going to the moon, the Artemis mission. And so culture is very hard to correct. Toxic cultures and transform the culture when it does go bad. So I talk a little bit about in the second half of the book how we fix these problems.
So initially, when you started speaking, you were just using the word culture, and then you kind of clarified it, and you said research culture and how it changed over time, and it became an environment where it was no longer safe for people to question things. Why did that change come about?
And so Diane Vaughan talks about this in her book, The Challenge and Launch Decision. NASA transformed from a research culture, it slowly evolved to what she calls a production culture, which is people are more focused on schedule and budget, producing vehicles, operating those vehicles and turn into an operations culture. And the really good researchers and engineers were no longer having hands-on experience developing new technology, testing it to failure and understanding it. They were looking over the shoulder of contractors and other people creating the hardware and developing that hardware. And so when you're stressed to produce on time and on budget, and you're rewarding behavior that allows you to keep flying, right? And you're rewarding that behavior that gives you the rationale to continue to fly. And when you look at people that raise serious problems and they're impeding that progress, that production culture, that schedule to meet schedule and budget, those people are not rewarded and sometimes they're vilified.
Mm.
And so it becomes a very toxic culture where people become afraid to speak up. And because I was embedded at NASA for so long, I worked in multiple different cultures. It's not just one culture. Each NASA center has a different culture. And then when you dive into each of those centers, they have multitudes of subcultures. The astronaut office was very much a different subculture within that space center at Johnson Space Center. And so you have to understand that, and you look for those behaviors that identifies all these different cultures and what they do.
And do you think that this is a problem in other businesses as well throughout the country?
A- Absolutely. And so in my book, I talk about a couple of different other industries. The aircraft industry, I talk about 737 MAX, very, very similar to the loss of that technical excellence. People were very much interested in the bottom line, satisfying their shareholders. And so when you had the 737 MAX failures, Boeing right away, one of the things that came out was that it was a cultural problem. When they merged with McDonnell Douglas and the CEO from McDonnell Douglas took over, they were very much being stressed to satisfy the bottom line for their shareholders. And budget and profit was most important. And so the voice of those really good engineers was being pushed down. People that were impeding that profit, that flow, and raising issues, they were being silenced in that organization.
Wow. Can we just backtrack a little bit? I mentioned earlier that you're from Ozone Park, which this show takes place on Long Island, and I was wondering if you could just tell us a little bit about your journey from there to becoming an astronaut and what that was like.
Yeah, yeah. I'm an old guy, Tom. I was a teenager, early teenager during the Apollo mission. I grew up, my dad was a butcher, small family butcher shop in
Oh
Ozone
wow.
Park, Queens. And I was that little geeky kid that was into science and, had to go out and tough it out in the park and play sports with all my buddies. But when I would be home, science was everything. And it was you don't know, you're too young to remember, but the Cold War was raging. We were doing the drills,
Mm,
in my little Catholic high school in Ozone, elementary school in Ozone Park, Queens, in case we had a nuclear strike by the Russians. And
wow.
so it was us against the Russians, and the Mercury 7 astronauts were like my heroes.
Hmm. So they were your heroes, and then you decided to go into it, and how did that all come about?
Well, yeah, I was very much into science, and so I had uncles that worked at Grumman. My one uncle, Uncle Arnold, they were all out in Long Island, and I very much was interested and found my calling was going to be in engineering, and so I went to high school at Archbishop Malloy High School in Queens. And when I graduated, I went to Brooklyn Polytech and I majored in aerospace engineering. And I was very lucky between my junior and senior year, we had the opportunity to intern at NASA Langley. And several of us went to NASA Langley, and I interned there for 2 months in the summer between my junior and senior years. And it was then I realized I really wanted to do research. I had these unbelievable mentors that were the tops in the field in structural mechanics, aeronautics, aerothermodynamics. And during those 2 months, that's what really made me realize that research was my calling. And I was lucky enough to get hired and spent my first 22 years right out of college going to Hampton, Virginia, and working at NASA Langley.
And at what point did you realize that you wanted to go up into space?
I always wanted to, to be an astronaut. That was one of my dreams. And so when I first applied to NASA and was hired by NASA in 1978, 3 years after I was hired, NASA was put out a call for non-military pilots to be astronauts. And I was very unqualified. I only had a bachelor's degree. I had the minimum amount of requirements for as far as working for 3 years. And I applied and wasn't selected. And I only reapplied 18 years later when I had custody of my daughter. I was divorced at that time, and I could get custody of my daughter and I could leave Virginia. I applied when I was 44 years old,
Wow.
and I lucked out. And I was the oldest rookie astronaut to fly in space. When I actually flew, I was 53 years old.
That's amazing. That's really incredible. Um, I mentioned earlier that you were on the first mission after the Columbia disaster. Can you talk a little bit about the Columbia disaster and what it meant to be involved in the next flight to go up after that?
Well, I have to tell you, Tom, I was raising hell when I came back from Russia. I never thought I was ever going to fly in space because I was really pissing off a lot of the program managers and the flight directors and even some of the engineers at NASA Johnson Space Center. And I was looking at what they were doing. I wasn't happy with how they were conducting the return to flight effort. I wasn't happy with the effort they had going on trying to understand what caused the accident. And so I went to the head of the astronaut office. I said, you know what? I don't need to be an astronaut. I've worked all over the United States with different people on hypersonic vehicles as a researcher. Let me help put together these teams to help solve these problems. And my boss, Kent Rumminger, at that time, said I didn't have to leave the astronaut office. He would let me go and form these teams. And so I spent a lot of time forming these teams to understand what caused the problem. And I was working on a team that was coming up with solutions to actually repairing the wing leading edge in case we got damaged by a debris hit like Columbia got hit with. We had developed a repair kit that astronauts could go perform a spacewalk and fix the vehicle while in orbit in spacesuits. And so I was busy doing that when I got the call from Kent Rominger. Told me, it asked me if I wanted to be on the next flight
Wow.
after Columbia, and I said, yeah. And it was an amazing opportunity. I flew with Eileen Collins, was the first female commander of Space Shuttle. This was her second flight as a commander. Jim Kelly was the pilot, Wendy Lawrence, Steve Robinson, Andy Thomas, and one of my classmates from Japan, Soichi Noguchi. And it was an amazing opportunity. And we trained for about 2 years because, of course, we were down for about 2.5 years after Columbia. So we had to develop a whole lot of new technology. And we were testing that technology on this next flight. So it was a research engineer's dream to be able to be on that mission.
And did you have more than one would expect fear after the previous disaster, or is it just something that because you dedicated your whole life to it and you're a problem solver that it was just something that you just had to do?
Yeah, it was. I really didn't have any fear. We trained, and we have amazing trainers at Johnson Space Center. They do a very good job, and we trained very hard. I felt that we were going to be as safe as we would ever be, probably safer, of course, because we had new technology that we had developed to inspect the vehicle. We could use the space station supposedly as a safe haven, and they could send up a rescue vehicle if we did have severe damage. And so we thought we were safer. We thought we would be safer, but as astronauts, I always knew that the probability of failure was about 1 in 67
Wow.
that we would lose our lives. And so we accept that, and that's something we sign up to do. And but of course, we flew on the return to flight mission. Right after that, I was the director of engineering, and I had to make a call: are we ready to fly? And in putting my director of engineering hat on, there were things we needed to fix. And I stood up at a flight readiness review and said, no, we're not ready to fly. And I was 3 days later, I was reassigned.
Oh, wow.
And so immediately I realized the culture was not safe. It wasn't psychologically safe. And I was reassigned, and I worked in the safety organization that had just been created, the NASA Engineering and Safety Center. I was a deputy there. And what happened was I found another problem with the spacecraft. With all three shuttle vehicles, we had wing leading edges that had serious problems. And they were in the highest heated regions of the wing leading edge. And so it was very critical. And we were continuing to fly. And so I talk about how I was threatened, how I was treated, mistreated, if you will. And it's 18 years after the fact, and I didn't want to be a whistleblower when this happened, and I stayed with NASA because I wanted to help fix this problem. But when I saw these problems, I had to write about them because people wouldn't understand how bad a culture could affect the decisions that people make in an organization. Even NASA, people think of NASA as this shining castle on a hill that could do no wrong, this amazing organization. They could believe it of industry that are focused on profits, maybe, and that could be that corrupt. But I had to show that in the first half of the book so that people realize how badly cultures can affect how an organization behaves, and it could cause tragedies. And so I devoted the second half of the book And I continued working at NASA because I felt like I discovered something that could help other organizations fix their cultures. And that's what I talk about in the second half of the book. How do you go about doing that?
In recent years, there have been whistleblowers coming forward about the airline industry, and some of them died unexpectedly. It seems like in all different areas, whistleblowers are at risk. And it sounds like your experience was pretty tough. Luckily, you're still here to talk about it. But this idea that uh, that people cannot come out and speak about situations that might be saving people's lives is just shocking. Um, can you explain how it gets to that point?
You know, I can't understand it, Tom. I grew up in a very safe environment in a research culture where we encourage people to speak up and find problems. And what really upset me was I tried to explain this to the administrator of NASA, and I would do this almost every year. I would reach out to the administrators, the new administrators of NASA, the heads of the safety organization, and beg them to have me come and talk about this because they don't quite get it. They don't understand it. And unless you understand culture and sociology and behavioral science, it's totally alien to people that grow up with a technical background. Plus, they don't believe it's a real science. And so when I reached out most recently in like 2022, 2 years ago, I reached out to the head of NASA. I said, I'm going to write this book. But I think you need to hear how bad the culture is at NASA because it's still bad. And Bill Nelson didn't listen to me. He had me talk to his deputy and his associate administrators, and they listened to what I had to say. I presented basically the first half of my book to them, and they basically blew me off. They didn't believe me. And then I said, you know what, that's okay. I'll just finish writing the book, and maybe other people could learn from this. When I realized that the Artemis program, the program going to the moon, had serious problems that NASA was covering up.
Mm.
And when I realized that they were covering up these problems with the heat shield, I reached out to NASA again and I begged them to let me work with them to help form these teams like I show the teams that I was able to create in the book with great people at the research centers, and we were able to solve these very complex problems. And they basically told me no. And they went about trying to solve this problem the same way they did and have been doing for many years, which led to Columbia and Challenger accidents. And they were listening to the same people that were on the same teams that didn't realize we had serious problems during Columbia and Challenger, really during Columbia and post Columbia. So they were listening to the same people that weren't able to solve critical problems in the past. And they were putting together teams that I was really worried weren't going to be able to solve the problem. And so now we're 2 years down the road, and NASA wants the next astronaut crew on Artemis 2 to fly around the moon with the same heat shield that had serious problems in the previous flight in the Artemis 1. Artemis 1 flew around the moon, came back, had serious problems with the heat shield that NASA basically covered up. I started raising issues on LinkedIn and in social media, calling NASA out that they were covering this problem up. Finally, the Inspector General wrote a report evaluating the whole Artemis program, and they showed pictures of what the heat shield looked like. And it was for everyone to see. And so NASA had to address it.
Just for regular listeners and novices like myself, it just seems amazing that we were able to go to the moon so long ago,
Yeah,
and that we
yeah,
haven't done it since. Um,
yeah.
and it seems like such a challenge now to do it. Like,
Well,
why did we stop going? Why is it so hard to do it anything even remotely close to it now, in your opinion?
Because it's Tom, this is a very good question. When I say we lost our research culture, when we stopped doing research in thermal protection systems, advanced propulsion systems, advanced structures, we stopped gaining knowledge. And so when we tried to develop a heat shield, we used exactly the same heat shield. We tried to duplicate what we had done during the Apollo program. We were never able to recreate the magic, and our heat shield that we had for the Artemis program was never as good as the heat shield we had during the Apollo program. Okay. Now, some people had been doing advanced work in advanced heat shield, but NASA selected this concept using what they call an Avcoat material, and they filled honeycomb cells with it, just like we did for Apollo. But then they decided to go away from that design and use just block Avcoat, blocks of this Avcoat material, which they would glue onto the base of the heat shield, the bottom of the capsule, to use as the heat shield, and it had serious problems, and they weren't able to solve those problems. But what when I'm talking about a research culture, we did not advance the state of the art in thermal protection systems incrementally, but we had no major breakthroughs in new technology for that many years. And NASA lost its capability to do that, and so the Artemis the SLS space launch system that NASA is looking at is basically developed to fly our astronauts back to the moon, is using 1970s technology. And what we're seeing today, just today, New Glenn launched with new thermal protection systems on that, and we're going to watch SpaceX launch Starship 7,
Hmm.
which is looking at advanced thermal protection systems. They're doing the research. We are not at NASA,
Wow.
and that's why we need to get back to the model that we had during NACA, where NASA is doing the far-term research and they're developing those technologies and handing it off to our partners in industry.
It's not every day I get to speak to an astronaut, so I just want to ask you about a couple quick things that have been in the news, if you don't mind. With all your knowledge, what do you make of these recent drone sightings all over the place that have been acknowledged by our government? It's the strangest thing, and I mean, with your engineering background, these things are moving in ways that uh, they say they don't understand how they're doing it. Um, what's going on?
You notice you don't hear anything about drones anymore.
Yeah.
I think we know what the drones were doing, and it was just a matter of the government talking to the different cities and localities where they were flying to explain to them what was happening and what they were doing. You notice they had red and green lights on them when
Hmm.
they were operating, so they were. It wasn't like a foreign power that was sending these over on military bases. I believe it's something we know about, and they're conducting experiments, if you will, and our government knows about it. They just didn't relay that information to the local sources. And so when people start seeing these things flying around, they get a little upset, they get a little worried. But the civilian drones, that people flying drones you just saw in the fires, if they don't file a flight plan, if they don't follow FAA regulations, they could disrupt air traffic, and
Yeah.
we could have accidents. We almost lost one of those ships that was carrying water to fight the fires.
It's amazing. So you think they're drones, and that we're just testing things out, but aren't they doing maneuvers that science-wise we haven't really acknowledged yet? Like the way that they're flying. I mean, and there's these Air Force pilots who are coming out saying that they've witnessed things and videotaped things that they can't
Right.
explain.
Right. I saw even my good friend Leroy Chow, who was actually training in Russia with me. was saying that he's a general aviation pilot, and he had seen these silver orbs, if you will, flying around. I tend to think it's probably new technology that we're experimenting with that's out there, just like when we test new hypersonic vehicles or new high-speed aircraft.
Mm.
It could be secret programs, it could be black programs. I haven't seen anything that makes me think they're aliens, if you will.
Yeah, like I'm not even implying that. I have no idea, but I'm just amazed that if they do have this new advanced technology and they're testing it all out, then why can't they get the heat shields right to go back
Well,
to the
that's
moon?
no. It's a really good question. We stopped doing work in that area, and back when I was working in hypersonics, which was my area of my specialty, was working in hypersonic structures, and we called it the thermal structures branch. When I was at NASA Langley, I mean, we were leading the world in hypersonic research and hypersonic developed technology. And what you see right now are the Russians and the Chinese have eclipsed us. They are ahead of us. They have operational weapons, hypersonic weapons, and we do not. And this is a critical problem for our country. When we stop doing research in these critical areas, not only for space travel but also for our military, it could be it could have serious problems, serious repercussions.
Do you have 5 more minutes or so?
Sure.
Okay. You mentioned SpaceX. Couple things. How do you feel, as someone who has worked for a program like NASA, that there are these private companies like SpaceX that are making advancements in space exploration? And also, what is your opinion about the eventual Mars mission?
Okay, I think what is happening right now, Tom, is the natural progression, just like we of if you look at air travel, right? We developed and the government funded people to develop aircraft, right? But the aircraft industry is totally owned by industry. It's commercial. They build the airplanes. They ensure that the airplanes are safe. Now NASA conducts a tremendous amount of research to make aircraft more efficient, more safe. We influence the use of composite materials in commercial aviation. We need to continue doing that advanced research now and let industry fly humans in space. NASA, Johnson Space Flight Center was a little arrogant when we started looking at commercial space flight. They thought they were the only ones that could certify humans to fly in space and could create a human rated spacecraft. And we know that's not true. And Elon Musk and Jeff Bezos and other folks are proving us wrong. And so this is the natural progression of things. We have to hand this off. I think this is a critical, it's almost a tipping point where NASA has to have a new mission. It needs to go back to its research, applied research roots, and be a partner with the aerospace industry, the space industry, and the commercial space companies like Jeff Bezos at Blue Origin and Elon Musk at SpaceX.
Do you support the idea of going to Mars?
I love the idea of going to Mars, and I'm right on board with Elon Musk. I think we need that challenge. I think, unfortunately, if it's a space race to the moon, I'm not sure we could beat the Chinese to the moon, but I know for sure we could beat the Chinese to Mars. And and I think we need to push out, and that should be what we should be doing. We should be looking at something further out there. Going back to the moon, if it's for a strategic military reason, maybe we have a base on the moon. But I would leave it up to the commercial space companies to determine where the market is. Where do they see that they can derive profit?
As someone who has flown in space, can you just give our listeners a little sense of what it would like, what it would be like for an astronaut theoretically to fly to Mars?
I was only up in space for 14 days. My good friend Don Pettit, who was in my class, and he's 69 years old. God bless him. He's on space station right now at 69 years old. Has over 400 days in space. He's a natural a Martian, if you will. He would be the type of person, and we have amazing people in the astronaut office that can do this and can survive for years in space, if you will, or on another body, heavenly body. And it's going to take, those are the next explorers, just like we've had explorers on land, crossing the seas. These are the explorers that we need to send out there. But we need to make it safe for us to fly hundreds of people in space, for you to want to fly your family in space. The odds of surviving have to be a lot higher than 1 in 67
Yeah,
or 1 in 100, right?
yeah. Um, you mentioned you were in space for 14 days. What That's still remarkable. What was the most precious moment that you had in those 14 days that you were up in space?
You know, a lot of people don't know this, but my commander, Eileen Collins, you should definitely have her on your show. She just had a new movie come out. It's going to be coming out called Space Woman, talking about her life. And
Wow.
and she is an amazing person, and she has a tremendous story. And she was also a New Yorker, grew up in New York.
Hmm.
But what was it like? What was the greatest thing? Because we flew after the Columbia accident, what people don't know, but if you watch this movie, what you will learn is we had an Apollo 13 moment where we almost didn't make it back home. And when we were up in space, and people that were watching the movie didn't realize that this happened, we had an anomaly. We had a piece of material come out from between the shuttle tiles on the belly of the vehicle. It was called a gap filler in
Wow.
between each of the shuttle tiles in two places. And it only stuck out about an inch in two places near the nose of the vehicle. And because we had these new procedures and this new technology to video record and photograph our vehicle to see if there was any damages, there was any anomalies, we noticed these pieces. And the people on the ground at NASA Langley basically did the analysis and said, if we don't do an emergency EVA spacewalk and remove that, we're going to perish. We won't survive. Our vehicle will burn up. And so the most amazing moment for me in space was the ability that we had to work as a crew for 2 years to train as a crew with amazing people on the ground that looked at this issue. And in a day and a half, we solved this problem as a team, working together with the trainers, other astronauts going in the neutral buoyancy lab, doing the simulation, people doing the procedures for the robotic arm, how we would have to move the astronaut and make sure he reached the bottom of the orbiter safely to pull it out. And so the greatest moment was working together with this amazing team. And so I talk a lot in the second half of the book about how do you create these high performing teams? How do you train these teams? And how do you operate as a network of high performing teams to solve these very complex problems? So to me, it was that rewarding feeling of being with this amazing team and doing something that seemed almost impossible to basically save your life in space. It was much more difficult than some of the procedures that needed to be done for Apollo 13, and we pulled it off. And it was just amazing effort by hundreds of people.
That is awesome. That's an amazing story, and you can learn more about that story if you read Dr. Charles Camarda's book. Um, it's an amazing story, and it has really important information in there, warnings to people about the importance of research. And why don't you tell everybody about the book and Mission Out of Control and where they can find it?
Sure. And so the first half of the book, unfortunately, I talk about how do great organizations lose their way, lose their core ideology, become toxic, and end up causing recurring accidents if they're not able to transform that culture. And the second half of the book, I talk about ways that organizations can actually identify when they have problems and then how they go about fixing it. And you can buy the book at Amazon. You could go to missionoutofcontrolbook.com or you could go to charliecamarda.com.
Well, I want to thank you. It's such a thrill for me to have a chance to speak to you. You're welcome back on the program anytime. There's a lot more to discuss with this book. I hope that people around the world learn from your system of studying issues and analyzing problems ahead of time can help other organizations because it sounds like really good advice. Dr. Charles, thank you so much for joining us on the program, and I wish you the best.
Thank you very much, Tom.